Hello students, welcome back to Aim High, Think Big. Today, we are going to start one of the most important and interesting topics of Class 10 Science, concave and convex mirrors from the chapter Light, Reflection and Refraction. In this session, you will learn types of mirrors, image formation, ray diagrams, mirror formula, magnification, sign convention, and many important CBSE concepts and numericals. This topic is extremely important for board examinations, numericals, competency-based questions, ray diagram practice. So stay focused, keep your notebook ready, and let us begin this exciting journey into the world of mirrors and light. Let's aim high and think big. Before we move ahead, let us first understand what we are going to learn in this chapter. By the end of this session, you will be able to differentiate between concave mirror and convex mirror, understand important terms like pole, focus, center of curvature, principal axis, learn the important ray rules used in image formation, draw accurate ray diagrams for different object positions, understand real and virtual images, erect and inverted images, magnified and diminished images. Apply the mirror formula and magnification formula correctly. Students, remember one important thing. This chapter is not about memorizing only. It is about understanding how light behaves when it strikes a mirror. So observe carefully, think logically, and practice the ray diagrams neatly. Students, mirrors whose reflecting surface is curved are called spherical mirrors. These mirrors are parts of a hollow sphere. There are mainly two types of spherical mirrors, concave mirror and convex mirror. A concave mirror has its reflecting surface curved inward, while a convex mirror has its reflecting surface curved outward. Concave mirrors are converging mirrors and can form real as well as virtual images. Convex mirrors are diverging mirrors and always form virtual, erect, and diminished images. We use concave mirrors in shaving mirrors and headlights, whereas convex mirrors are commonly used as rear view mirrors in vehicles due to their wide field of view. Now, let us understand the important parts of a spherical mirror. The center point of the mirror is called the pole, represented by P. The straight line passing through the pole and center of curvature is called the principal axis. The center of the sphere from which the mirror is formed is known as the center of curvature, represented by C. The distance between the pole and center of curvature is called the radius of curvature. The point where parallel rays meet after reflection is called the focus, represented by F. The distance between the pole and focus is known as the focal length. Students, a concave mirror is a spherical mirror whose reflecting surface is curved inward. It is also called a converging mirror because it converges parallel rays of light at one point called the focus. Concave mirrors can form both real and virtual images, depending on the position of the object. Real images are inverted, while virtual images are erect and enlarged. These mirrors are widely used in daily life. Dentists use them to see enlarged images of teeth. They are also used in shaving mirrors, vehicle headlights, torches, and solar furnaces because they can concentrate light effectively at a single point. Students, a convex mirror is a spherical mirror whose reflecting surface is curved outward. It is also known as a diverging mirror because it spreads the reflected rays outward. Unlike a concave mirror, a convex mirror always forms a virtual, erect, and diminished image, regardless of the position of the object. The image formed appears behind the mirror and cannot be obtained on a screen. Convex mirrors are mainly used where a wider field of view is required. Therefore, they are commonly used as rear-view mirrors in vehicles, security mirrors in shops, and safety mirrors at road turns and parking areas. Students, to draw image formation diagrams correctly, we must remember the important rays used in a concave mirror. The first important ray is a ray parallel to the principal axis. After reflection, it passes through the focus. The second ray passes through the focus before striking the mirror, After reflection, it becomes parallel to the principal axis. The third ray passes through the center of curvature and retraces its own path after reflection. These three rays help us locate the position, size, and nature of the image accurately. Practice these rays carefully because they are very important for CBSE examinations and numericals. Now let us understand the important rays used in a convex mirror. The first important ray is a ray parallel to the principal axis. After reflection, it appears to come from the focus behind the mirror. The second ray is directed towards the focus. After reflection, it becomes parallel to the principal axis. The third ray is directed towards the center of curvature. It reflects back along the same path. In a convex mirror, reflected rays always diverge, so the image formed is always virtual, erect, and diminished. These ray rules are very important for drawing correct CBSE ray diagrams and understanding image formation clearly. Let's examine image formation by a concave mirror. When an object is placed beyond the center of curvature, the image is real, inverted, and diminished. At the center of curvature, it is real, inverted, and the same size as the object. When an object is placed between the center of curvature and the focus, or between the focus and the pole, the concave mirror forms a virtual, erect, and magnified image behind the mirror. When the object is exactly at the focus, a highly magnified, real image is formed at infinity. Conversely, when placed between the pole and the focus, the image is virtual, erect, and magnified. To summarize, the position of the object relative to the mirror's components dictates the nature and size of the resulting image. Always follow the three principal rays to master these diagrams. Accurate calculations require following the sign convention. The pole is the origin. Distances in the direction of incident light are negative, and heights above the axis are positive. The mirror formula relates object distance, image distance, and focal length. Additionally, the magnification formula helps us determine the size and orientation of the image. Always apply signs carefully. Finally, practice using these formulas with numerical examples. Always write down the given data with correct signs, solve carefully, and include the proper units for your final answer. Let's review a summary of image formation by a concave mirror. Notice how the object's position determines the image's position, nature, and size. Keep these key takeaways in mind, such as the concave mirror forming real and inverted images in most positions, and remember the mirror formulas and the relationship between focal length and radius. Students, many marks are lost in examinations because of small mistakes in ray diagrams and sign convention. Always draw diagrams neatly using a ruler and sharp pencil. Mark the pole, focus, and center of curvature clearly. Never forget to draw arrows showing the direction of light rays. While solving numericals, use the correct sign convention carefully. Remember that real images are inverted and virtual images are erect. Practice mirror formula and magnification questions regularly to improve speed and accuracy. Most importantly, understand the concept instead of memorizing blindly. With proper practice and confidence, you can easily score full marks in this chapter. Students, today we learned about concave and convex mirrors, their properties, important terms, ray diagrams, image formation, mirror formula, magnification, and sign convention. We understood how the position of an object affects the size and nature of the image formed by a mirror. We also learned the important rays used for drawing accurate diagrams in CBSE examinations. Remember, regular practice of ray diagrams and numericals is the key to mastering this chapter. Revise the formulas carefully and focus on understanding concepts instead of memorizing them. Keep practicing, stay confident, and always aim high and think big. Thank you, students. Thank you for watching this video. I hope this summary helped you better understand concave mirrors. Remember to keep practicing and stay consistent to achieve your goals. Don't forget to like, comment, share, and subscribe to our channel for more science content. Good luck with your studies.